I will try to explain what is cloud, what is the cloud computing. It has been used in the software industry for a long time, but there are still many different descriptions of the cloud computing. At the beginning, cloud computing was about virtualization, but we managed that it is not only about that. Cloud computing is now often understood as storage facilities through web applications. Many people still understand that cloud is kind of advanced web application or web way of developing the application. Now, by some years that cloud computing has been used, we understand that cloud computing is mainly a software architecture, which is called REST. And what REST is the new simplified architecture, resource-oriented, with simplified operations, and mainly based on the HTTP protocol. What means resource-oriented? A resource in a REST architecture is an atomic structure which can be created, updated, or deleted as a rule. It replaces the old paradigms like object-oriented, relational, tables, or other paradigms. And for the operation on resources, we simplified the architecture using just simple operations, create, read, update, and delete, which replace many other operations or patterns which were used before. And how it is implemented is now we use the simple operation from HTTP, like get, put, delete, instead of language-specific functions or class or objects. So erOCCI is REST-oriented and is a framework for developing REST applications. So we can see simply as another framework for developing REST application. I will show you an example of such operations. So let me start the erOCCI framework, and I will create a resource. Okay, this is a resource I want to create. So I will use the curl command line interface to create my resource on the erOCCI framework. And my resource is created. I can read it now. And I retrieve my resource. This is a REST application. I can update my resource. And my resource is updated. My resource has been updated. And then I can delete the resource the same way with the delete HTTP verb. And you will see that the resource does not exist anymore. Okay. Okay, so erOCCI is a REST framework. But is it still another REST framework like another one? Not exactly. And this is what I will try to demonstrate, because there are many kind of REST APIs. REST APIs is just an architecture, and it's not a standard, and it's not REST API are not interoperable. They look similar, but they are not exactly similar. They are not based on the same on a single language, on a single data representation. erOCCI is based on the OCCI standard, which has been developed in the OGF, Open Grid Forum. And the difference with the other REST APIs is that first, OCCI is typed and is strongly typed. A resource is an instance of a kind and has an ID, which is a URI. So identified with the URI, this is something common in REST APIs, but a resource is typed with a kind. A kind is a named list of attributes and also holds actions. For instance, a kind is identified with with a kind of a URL, which is called a scheme. And an attribute in the OCCI standard, an attribute has a name, a type, can be mutable or not, as an occurrence, as a default value, so it's well defined. An action is an operation which can be invoked on a resource once a resource is created. For instance, we can have a compute resource which represents, for instance, a virtual machine, and we can invoke the start operation on that, the stop operation, the suspend, and so on. And kinds are inheritable, so kinds can inherit attributes and action from another kind. So we have a complete typing scheme. But OCCI is also extensible because resource are an instance of a kind, but they can be associated with one or several mixins. What's a mixin? A mixin is a named set of additional attributes and actions. It's like a kind, but it cannot be instantiated directly. It is just associated with an existing resource. For instance, we can create a resource of type network interface, and we can associate with it the IP network interface, which will add the IP address on the resource or gateway attribute or such other attributes which represent attributes specific to IP network interface. There's another way to extend OCCI resources. A user can create a mixin which will not have any attributes or action, but just a name. And this name will be associated with resources, which will allow to tag resources. I will show you an example. So I will create again my resource. So I have created the resource. Okay. And I want to associate a mixin. So I will add, to associate a mixin with a resource, I will add the resource ID to the list of resource of this mixin with the following operation. So the URL here is what we call the collection, which is the list of resources of the mixin, and I add my resource to this collection. Okay, a little mistake. Sorry. Okay, so I have updated this collection, and now my resources is listed in the resource of the kind OS template, as we can see here. I will show you also the creation of a user mixin. So I'm creating this mixin, which is called schema.example.org/OCCI, plain mixing. And I'm associating a location for retrieving the list of resources associated with the mixing. Okay, so it's a mistake also. Okay, I have created so a new scene which is located at this place, and I can associate resources with it, which will allow to tag the resource. So OCCI is extensible, and OCCI is also relational because it's important to define the relation between the resources, like in other paradigms, like relational SQL or such. So we have two ways of express the relations between resources. We have so-called links. Links are just specific resources with two specific attributes: the source attribute and the target attribute, which points to resource URIs. Then we have also the collections that I have already shown to you. So the collection allows to retrieve the resources by type and not only by the URIs. So let me show you the link. So a link looks like this, for instance. There is a category, there is some attributes, title, interface, MAC address, and the source attribute and target, which points to existing resource. And the collection I've already shown that you can retrieve resources by the kind. But OCCI is also self-described, which is really important because it will allow an OCCI client to discover the capabilities of the server and keep the client really simple without knowing the exact kinds and attributes that the server handles. It can interact with it, create resource with the right attributes. So there is a specific URI, which is /data/, which allows to retrieve capabilities, and I will show you this. Okay, so here I can retrieve all the categories handled by the server. There is the compute category with the title, the inheritance, the attributes, state, speed, memory, hostname, and such, and all other categories. These categories, which is mixing or kind, and also actions. So at the end, we can say that OCCI is based on a simple and strong meta model, which describe entirely and completely the relations and the typing of the resources handled by an OCCI server. And what allows that OCCI is based on a meta model, it allows that we can do consistency checking on a model. We can automate the implementation of models. We can represent an OCCI resource in different ways. I have shown you a single representation of an OCCI resource that I will show you later, but we can get the resource with other representations like JSON, XML, and such. We can transport the resources and all the REST API on other protocols than HTTP. Just to finish with OCCI, erOCCI is not the single implementation of OCCI. There are some frameworks, tools, specific implementation of specific models of OCCI. But all of these implementations are based on a specific language, and expressing an OCCI model with this framework must be done with the specific language, Ruby, Python, C, or such. So the exchange of models between this implementation is somewhat hard, and the interoperability between this model is not easy to achieve because we have to pass from a language to another. On the OCCI working group website, you can get a list of implementation. So here is the architecture of erOCCI, where we try to mimic the meta model of OCCI and try to respect the separation between the meta model, the rendering, and the transport. So I will go into details later, but basically you have several listeners which can transport the API on different protocols. You have different renderers which allows to represent the OCCI resources in a language or another, like JSON, XML, or such. We have the model management, which hold all the currency type checking and such, and all the creation and retrieval of the resources is handled by what we call backend. So now in details, we handle multiple representation of OCCI, as I said, and we handle the four different representations as of today. So the text plane, which is the representation I've shown you on the demo, but there's also the text OCCI representation, which is the same representation but in HTTP headers. The JSON representation, so we represent the same information in JSON, or the XML representation. It represents the same data, but in another language. So the JSON representation is still a draft for the OCCI standard, but it has been implemented in different implementations already. The XML representation is experimental, but we have an XML schema, which allows to check precisely the syntax of the XML. And of course, we have a clear API in erOCCI so that you can write your own renderer. You just have to implement the rendering and the parsing of the data. We have multiple backends, so we can store the data in different kind of database or interact with existing APIs. The backends are attached to mount points in the server, like a file system. So you can have different backends running in parallel in erOCCI. The backends declare a schema to the erOCCI. So it means that you can handle any kind of any mixing in a backend. And if kinds of mixing are done by several backends, the requests run in parallel in erOCCI. If you want to write your own backend, you just have to implement the CRUD operations, which means create, retrieve, update, or delete of resources. We handle also multiple transport. As of today, we handle the HTTP family protocols, HTTP, HTTPS, which is, and we have based it on Cowboy web server, which is a pure Erlang web server, which means it's easy to port to any architecture. It is a small server, well-tested, scalable, and really dedicated to REST APIs, so it's really compact. We have also implemented the XMPP transport, which is more targeted to M2M or IoT domains. We have based the XMPP transport on a fork of the eXMPP library, which is the most known XMPP library in Erlang. We use iTunes for that, and we have defined an XML schema for the exchange of REST operations on XMPP. And of course, the transport also is extensible. We have an API to implement the transports, and you can benefit if you want to write your own transport. You can benefit for all the erOCCI framework for dispatching requests, parsing and rendering, the fault tolerance and such. So the goal is to benefit from a lot of libraries, so that the implementation of a specific transport is as small as possible. So in a few words, if you want to extend erOCCI, you have several ways of doing that depending on your needs. First, if you just want to write, let's say, a REST storage or REST ORM, you just have to choose a storage backend, like the Mnesia backend, which is based on a distributed database. You load the OCCI schema as an XML file, choose a listener for the transport, and just start the framework. And you don't have to write any line of Erlang. If you want to use erOCCI as an adapter to an external API, to have a gateway between, for instance, an OCCI API and another REST API, you can write your own backend. You just have to implement the CRUD operations and call your favorite API from that. You need to write Erlang. It's not so complicated, but it's not really usual. But you can benefit from the scalability, the fault tolerance, the different transports and such. And if you want to write a new transport, you can benefit from erOCCI because you can share the model, because the model is independent from the transport, and you just have to write the transport. So we have a lot of items in the roadmap. First, it is the authentication, authorization part, which has not yet been implemented. We want to write something independent from any specific technology. We want to handle X509 certificates, HTTP authentication, XMPP rosters, and such. We thought about POSIX-based authorizations, maybe with a file-based backend, but it's just idea. We have begun to write tests because we want to keep everything small and well tested. So functional tests are already existing, and we have begun to migrate them to common test framework, which is the Erlang functional test framework. But there's still work to do. We have begun to implement unit testing, but of course it is not finished. We have a component in another item is that there is a component in erOCCI, the OCCI store, which is a central point in the architecture because it is used to dispatch the operations. manage the multiple backends. So this is a real central point. It can be a bottleneck. So there's some work to optimize this orchestra, even if we have interesting performance today. The XMPP listener is kind of experimental because we don't handle yet the rosters, which is the groups in XMPP, the presence, and there's a lot of interesting XMPP extensions that could be implemented in the XMPP listener. There's also a specific part of XMPP to group to act as an API proxy, which is called XMPP component, and which could be integrated to implement to have a bridge between erOCCI and external APIs. And of course, we have in the roadmap to write new storage backends. We have started a REACT backend, which REACT is a NoSQL distributed database. We want to write also an ODBC backends to interact with any SQL-based database and so on. So of course, contributions are welcome. If you find erOCCI useful and you want to, you have another idea, just go to the bug tracker and fill a new task. Here are all the information for contacting the project. There's a website which is not complete today. The source code is on GitHub, and you have a bug tracker also. We have already continuous integration based on Travis, which means each commit in erOCCI is validated against some tests. And we have mailing lists to discuss about erOCCI.